Welcome back to Debian Mastery in Lesson 21, where we finally put a deployment substrate under everything we've built. The fleet is already healthy and managed. Backup from Lesson 18, monitoring from 19, Ansible from 20. Now we add containers. Over the next few slides, we'll walk a four-part arc: the runtime mental model, Docker versus Podman, why Rootless is the 2026 security default, and how compose and system quadlets turn services into code. Beat one of the arc, the mental model. Three words trip up almost everyone: image, container, runtime. So let's pin them down. An image is a blueprint, a layered tarball following the OCI spec. A container is just a running Linux process from that blueprint, wrapped in namespaces for isolation, cgroups for resource limits, and overlays for a copy-on-write layer. The runtime, Docker or Podman, both speaking OCI, is what stitches those kernel features together. That's it. A container is not a VM. It's a normal process with restricted views of the system, and once that clicks, every command you'll type for the rest of this lesson stops feeling like magic. Beat 2. Which runtime? Docker and Podman both ship in Debian, both speak OCI, so images move freely between them, and the CLI is so close that Podman run and Docker run are essentially aliases. The real split is architectural. Docker leans on Dockered, a long-running root daemon and a single point of failure, while Podman is daemonless. Each command forks a normal process you can run as your own user and supervise with systemed. That's why Rootless is first class in Podman, why Quadlet turns each container into a proper container unit, and why the Dargslan default for 2026 is Podman. If you already run a Docker fleet, keep it. They coexist fine, but greenfield work starts with Podman. That said, plenty of you are running Docker today, so let's install it properly on Debian. Skip the docker.io package. It's fine for a laptop, but production wants the upstream repo for current stable and faster security turnaround. Add Docker's keyring, drop in the sources list, then pull Docker CEA, the CLI containered, and the compose plugin in one apt invocation. The system unit is wired automatically, so system.ctl status Docker confirms you're live, and Docker run hello world proves the daemon answers. Adding yourself to the Docker group is convenient, but effectively grants root. We'll unpack that trade-off next slide. After that, 90% of your day is just 4 commands: pies, logs, exec, and restart. That trade-off is exactly why Podman wins in 2026. With rootful Docker, a container escape gives the attacker root on your host. With rootless Podman, the same escape lands them as your unprivileged user. Same blast radius, as if they'd fished your SSH key, not catastrophic. The magic is the subuid and subgid mapping. Debian gives your user 65,536 UIDs starting at 100,000, so the container's root is just a remapped namespace ID on the host. One catch: unprivileged users can't bind ports below 1024, so map high, redirect with NF tuples, or lower the SysAdmin threshold. Now, real workloads aren't a single container. You've got Postgres, your app, an Nginx terminator, maybe Redis. Compose declares the whole stack in one YAML and brings it up as a unit. Look at the key moves here. Pin the Postgres major. Pull the password from the INV we built in Lesson 20's vault work. Gate the app on a real health check rather than a naive depends on. And name your volumes so compose down doesn't nuke your data. 1. Compose up. D in the stack is reproducible. Same on your laptop, same in staging, same in prod. Compose is great for dev, but in production, you want one supervisor, not 2. And that supervisor is systemed. Quadlets are Podman's answer. Drop a container file into your user system directory, and Podman generates a real service unit at boot. You get timers, journal logs, restart policies, dependency ordering styles, all native. Notice the structure, standard unit, and install sections, plus a container block where Podman does the translation. After daemon reload, it's just system.qdl, user start. The container is now indistinguishable from any other service on the box. Enable linger so it survives logout, and you're running the 2026 production pattern. Once your containers are running as system units, the operate stack from earlier lessons just absorbs them. Restick from lesson 18 backs up named volumes under choch var lib docker volumes, but for databases, add a page dump all in exec start pre so you capture a consistent snapshot, not bytes mid-write. For monitoring, node exporters cgroups collector already exposes per container CPU and RAM. Kdvisor gives you richer detail if you want it. Then layer Prometheus, alerts on restart loops and kills. Same patterns, same tooling. Containers fit the stack, they don't replace it. Now, a reality check before we wrap up. Containers are a tool, not a religion. And Debian's packaging system isn't legacy baggage you need to escape. Stateless web apps, multi-tenant SaaS, dev environments. Yes, containerize, but SSHD, cron, journaled, kernel modules, a 5-line bash script, leave them alone. apt plus systemed has handled host-level services beautifully for decades, and a single-tenant Postgres on one host. Honestly, apt install PostgreSQL is often the right call. Pick by your team's skill, not by fashion. Now, 5 gotchas that will bite you in production. Number 1 is the big one. Adding users to the Docker group is handing out root, a quick Docker run v achat host, and they own the box with no audit trail. Treat it like sudo or sidestep it entirely with Rootless Podman. The other 4 are classics. The latest tag breaking deploys overnight, anonymous volumes evaporating your database on rebuild, depends on without a health check causing restart loops, and unbounded JSON file logs filling the root partition until Docker simply stops. Pin your tags, name your volumes, gate on service healthy, and cap your log driver or pipe to Loki, call back to lesson 19. So let's wrap lesson 21 with the 6 skills you now own. The runtime mental model, image plus runtime plus a namespaced C-grouped process, the Docker versus Podman split, with Podman as the 2026 default, rootless mode via subgid mapping, so a container escape doesn't equal host root, compose for multi-container stacks, system quadlet to run containers as proper units with no daemon, and finally, backup and monitoring glued in from lessons 18, 19, and 20. That closes the operate stage. Next up, lesson 22. In-place release upgrades, bullseye to bookworm to Trixie, with a safe rollback path, the skill nobody talks about until it bites. Containers deployed, runtime model, rootless Podman, compose plus quadlet, and the L18, L19 glue, all checked off. Next up, lesson 22, the in-place dist upgrade from bullseye to bookworm to trickeye with the pre-flight checklist, a real rollback path using LVM snapshots and restick, and the release upgrade playbook the official docs quietly leave out. See you in lesson 22.